Good afternoon. My name is Jaden Cruz, and today I will be talking about neural stem cells and brain repair. In this short presentation, I'm going to go over the recent discoveries in stem cells, their applications, and how it has all related to our course so far in Biology 1406. Let's begin. Oops. First of all, I'd like to start off with what are neural stem cells? Well, neural stem cells, or NSCs, and anytime in the presentation I refer to an NSC, I'm of course talking about neural stem cells. Anyways, neural stem cells, or NSCs, are multipotent cells found in adult brain regions like the subventricular zone and hippocampus. That would be this section right here, and this section right here, and they both are over here. They can self-renew and differentiate into neurons, astrocytes, and oligodendrocytes. They have limited activation in the adult brain, but hold therapeutic promises due to their neuroregenerative capabilities. And basically what that means is, say you have a stroke and you lose all mobility and control over the right side of your body. Well, what a scientist can do is get some stem cells, put them into your brain near the subventricular zone and hippocampus, and it will start to mend the severed connections, and you will eventually regain control of that side of your body that you lost control of. Next, I'd like to talk about NSC's connection to Biology 1406. First, cellular differentiation and stem cell biology. NSCs illustrate classical examples of potency and regulation of gene expression in cell fate. I believe we did go over that earlier in the month about gene expressions. Second, tissue regeneration and neuroplasticity. This demonstrates adult neurogenesis and how the brain can rewire after injury. That, of course, goes back to what I was saying earlier about the repairing severed connections and regaining mobility. Molecular signaling pathways. Studies utilize MAPK/ERK signaling to direct neuronal differentiation in therapies. Application of lab techniques. CRISPR or CRISPR screens, in vivo animal models, advanced biomaterials, all funnel lab methods taught in Biology 1406. That just basically means that in many labs where we have to look into the biology of different animals, we would be currently looking at their stem cells. I'd like to talk about the recent breakthroughs and updates with neural stem cells. First of all, injury-induced stem cell niches, however you prefer. Injured brain tissues, example stroke, form specialized niches via astrocytes and endothelial signals, example SDF-1A/CXCR4, supporting transplanted and indigenous NSC integration. Now, to summarize that is saying, this picture over here actually represents it. The severed pathways with neural links get repaired. So say right here is a pathway. The neural we have the pathway. The neural stem cells repair that pathway, making the connection whole again. Stroke repair via NSC therapy. This relates to what I was talking about earlier as well. Preclinical studies show NSCs release trophic factors, reduce inflammation, promote angiogenesis, and may replace damaged cells in ischemic stroke models. That, of course, is relating to my whole interest in stem cells in their ability to have the person regain control after a stroke was suffered. Clinical trials are now underway evaluating stem cell grafts' safety and mechanistic action in stroke patients. I believe that now it is regulated and is an available procedure to have, which is good news all around. And finally, graphene nanopatches for TBI. NSCs wrapped in wireless graphene nanosheet nanopatches receive targeted electrical stimulation via rotating magnetic fields. Increased differentiation into neurons 41% versus 16% in 5 days. Significant functional and cognitive recovery in mouse models within 28 days, and promising integration of nanotechnology with stem cell therapy. So, that means that nanotechnology will help boost the already crazy healing factors of stem cells, perhaps making the time shorter or making the time more useful, regaining more control. I believe that's very cool. And here are the references, and I would just like to close up by covering more on my interest in stem cells. I will be honest, my interest did first begin with a Family Guy short where Peter had suffered a stroke and he went into a building with neural stem cells and he came out fine. And of course, at first I thought it was a gag, but after looking into it more, I realized that it is a real world cure for different stuff like that. And it just opened my eyes to this whole new world of medicine where it shows us that we can take stem cells and we can create new and we can regain mobility. Of course, this does all come at the cost of it being from, I believe, infants who are still in the womb. So of course it is still a very, very controversial procedure and it's still being regulated. However, it is showing great promise. A lot of patients have been cured using stem cell therapy, and I do believe that in the future we should all be using stem cell therapy. Or not all of us, but people who have suffered great accidents and they need to regain mobility, I believe they should go through stem cell therapy in order to regain mobility.